Yes, Assalamualaikum and very good morning to all of you. My name is Muhammad Syamil bin Muhammad Aziz. My matrix number is B0822104441 and I'm from BEEI 101.
Assalamualaikum dan salam sejahtera. My name is Nur Muhammad Alif bin Rusli. My matrix number is P0822100580.
Good morning to everyone. My name is Yap Chijian. I'm from BEEI S1 and my matrix number is B0822102278.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Multimeter bin Multimeter. My matrix number is B0822104454.
So, without wasting our time, let me show you about my team presentation today. Let's go.
My name is Yap Chijian. Today I will show how to measure the resistance, capacitance, inductance, voltage and current by using multimeter. So before we start, I would like to introduce the equipment that we use in this measure. So as you can see in this video, the equipment that we use is AC power supply, jumper, resistor, inductor, capacitor, multimeter and probe. This is the three components that we use in our measurement. So first is the 550 ohms resistor and 39 microfarad capacitor, and the last is 10.5 millihenry of the inductor. Today I will show how to measure the resistor by using the multimeter. The resistor that we use is 550 ohms. So before we measure the resistor by using the multimeter, we can identify the resistor by using the resistor color code. So as you can see in here, the first layer shows green color, which means 5. The second layer also shows green color also, which means 5 also. The multiplier shows brown, which means multiply 10 ohm. And then the tolerance shows plus minus 5%. Therefore, 55 multiplied 10 ohm equals to 550 ohm. Hence, we can say that before we measure the resistor, we can identify the resistor by using the resistor color code. The circuit that we construct in this measurement for measure the resistance, inductance, capacitance, voltage and currents is in series. In this video, the voltage that we use in the AC supply is 10 volt. In this video, this is how we measure the voltage for the resistor. So when we measure the voltage for the resistor, the multimeter shows the volt is 9.52 volts. Next, we will measure the voltage of the capacitor. As you can see, the measurement of the voltage for the capacitor shown in the multimeter is 1.539 or 1.54 volts. Then we will measure the voltage of the inductor. So in this video, the measurement that shows in multimeter that measure the inductor is 276.5 millivolts.
For measuring current, we use clamp meter because in this circuit we use AC supply, alternating current. For measuring the current, first we have to rotate the selector to 40 amp range. Next, we have to push the button on the side of the meter and clamp the input wire on the circuit. After clamp the wire, the reading will appear on the LCD meter.
Okay, for the simulation our circuit, let me explain about. First thing first, we use multi-sim software for construct our circuit. As you can see, this circuit we also construct in simulation method using a 3-component sim we use in our lab. First, we use the 515 ohm resistor, 39 micro capacitor, and 10.5 millihertz inductor. So, this is our result in simulation. As you can see, the 4 multimeter we use in our simulation show you the reading of multimeter.
In this discussion, we got comparison of measurement and also simulation. Voltage across each resistor connected in series follows different rules to that of the series current. From the result of doing lab calculation, for voltage resistor, we got 9.52 volt and 9.901 volt with using simulation. Continue for voltage capacitor, we got 1.54 volt and 1.464 with using simulation also. And for the voltage inductor, we got 267.5 millivolt and 59.751 millivolt with using the same simulation method. Furthermore, we got 20 millivolt for current from doing in the lab, and we got 18.001 millivolt from doing in simulation software. To answer the question about why the inductor voltage is not the same, because the value of the result of the calculation in the lab is not accurate. The one of the reason why is the probe for the inductor reading is not there and the same as well in the simulation. For the last one, this is the result of calculation that we have prepared as written here. And this is also how we complete each calculation as well as to get each volt through capacitor, inductor, and also resistor. At the end of this lab, we exactly know how to calculate our values for voltage, resistance, and current by calculation, and we absolutely verify the result by doing the experiment. Also, we can construct our circuit using software in Simulink. As, as a result, we got little bit different amount of errors in our experiment because we took the same current values for each component that we using series circuit. Last but not least, we prove the current is the product of voltage and resistance by keeping resistance constant.